So the matrix Aij of n by n is said to be rectangular matrix, rows not equal to columns. So the number of rows not equal to number of columns, it is called a rectangular and null or zero matrix. So all the elements of a given matrix is zero. All the elements of a given matrix are zero, then that is called null or zero. Diagonal. Diagonal is important. Okay. The matrix is said to be a diagonal matrix, but we know very well all non-diagonal elements are zero. For example, if we take, see here, diagonal matrix, scalar matrix, unit matrix. So these all are a square matrix. The diagonal is exists for only square matrices. For example, if I take here like A is equal to 1, 2, 3, 4, 5, 6. Is it a square matrix? No, it is not a square matrix. Okay, so we cannot take that diagonal. Okay, first of all, principal diagonal elements 7, 8, 9. So first we have to identify what are the principal diagonal elements or leading diagonal elements, right? These are the principal diagonal elements or leading diagonal elements. The principal diagonal elements or leading diagonal elements are here 1, 5, 9. 159. So this 159 are called leading diagonal. So remaining elements 2, 3, 6 and 4, 7, 8. These are non-diagonal elements. So to discuss the diagonal, simply remember that all non-diagonal elements must be zero. So don't think about the diagonal. So diagonal means at least one element is non-zero. Okay. So these elements all are zero. Then this matrix is called diagonal matrix. Okay. Diagonal matrix. Any one of the diagonal elements must be non-zero. Okay. So remaining non-diagonal elements all are must be zero. Right? That is called diagonal. So the example is that we can take 2 by 2, 1002. This is a diagonal of order 2 by 2. So diagonal is exist for only square matrix. So the matrix is diagonal. Aij is equal to 0. I not equal to j. I not equal to 0 means if I want to say this given matrix is diagonal, see 1 not equal to 2, nothing but this is 0, this is 0, here 1 not equal to this is 0. Like that. So other than this diagonal elements, so remaining all values are 0. Look at here, I not equal to j, every element is 0. Okay, so this is I equal to j, a11. Yes,
What's I and J?
sorry,
Oh, what's I and J?
I will represent here, clearly I have written I will represent the row. Okay, I will represent row and J will represent the column. So I is related to row and J is related to column. Okay, like for example here have written here Aij. Ith, okay, that row, I will represent row, J will represent column. Just we have to check that the row equal to column or not. So look at here, if you take here A11, this is clearly which is related to first row, first column. If I take 2, 2, this is related to second row, second column. 3, 3, 4, 4, 5, 5. So these are the diagonal elements. So non-diagonal elements means I not equal to j, 1 not equal to 2, 1 not equal to 3, 2 not equal to 1, 3 not equal to 1, like that. Okay. So whenever I not equal to j, all elements are 0. Okay, then that is called diagonal. Coming to scalar, this is a diagonal matrix, not a scalar. Scalar in the sense when I is equal to j, when I is equal to j here, okay, when I is equal to j, the value aij must be a constant, must be a scalar. Okay, like unique value. So here 1 2 means different values. It is just diagonal. This is scalar. Okay. So coming to unit means all diagonal elements must be equal to 1. All principal diagonal elements are equal to 1. That is identity. Okay. So this is about diagonal scalar unit. Right. Now we know that row matrix means 1, 2, 3, and column matrix means we can take as 1, 2, 3, like. Okay, row matrix, column matrix, when, so row means n is equal to 1, that's it. N is equal to 1. The number of rows is equal to 1, then that is called row matrix. Then column matrix. Column matrix means simply n is equal to 1. N is equal to 1. The number of columns is 1, then that is called column matrix. Okay. The number of rows is equal to 1. Only one row. Any number of columns. So that is called a row matrix. Okay, clear? So we discussed the addition of a matrix and the subtraction of a matrix. Okay, right. Addition. When I take any two matrices, 1, 2, 3, 4. Okay, then B is any matrix like 2, minus 3, 7, 4. Can you tell me what is A plus B matrix? Addition of any two matrix. So first of all, we have to remember that whenever we want to adding or whenever we want to subtracting any two matrices, their orders must be same. First, their orders must be same. Here, what is the order? 2 by 2. What is the order? 2 by 2. Because 2 rows, 2 columns. So, order is clearly same so that A plus B. Now, we can add in the corresponding elements. So, first element of A, the first element of B is 2. First element of A is 1. The first element of B is 2. So we'll do like this 1 plus 2. Next 2, the corresponding element is 3. 2 minus 3. 3, the corresponding element is 3 plus 7. 4, the corresponding element is 4. Okay, adding the corresponding elements, that is clearly equal to 3 minus 1, 10, 8, like that. So this is the addition of two matrices and addition, and coming to subtraction, A minus B. So can you tell me directly what is A minus B? So 1, first write here A matrix 1, 2, 3, 4, minus 2 minus 3, 7, 4. This is equal to what? Anyone? 1 minus 2. Just subtract the corresponding element. 1 minus 2 is minus 1 and 5. Because you know minus to minus plus 2 plus 5. And here it is clearly minus 4. 3 minus 7 is minus 4. 4 minus 4 0. Like that. So addition and subtraction is very very easy. Coming to multiplication is very important because most of the 90% of the question based on the multiplication, even in JE also, right? Fine. Let's see the multiplication. How to multiply the two matrices? How to multiply the two matrices, and also we will see some properties of addition. Okay, like coming to properties of addition, A plus B is equal to, we can write B plus A. So nothing but it is a commutative property. It satisfies. So matrix addition satisfies the commutative property, and matrix addition also satisfies associate property. That is, if we take any three matrices, so that addition of these three matrices, nothing but A plus bracket B plus C can be written as A plus B plus C. This is one of the property, and the third one is like A plus null matrix is equal to null matrix plus A is equal to A. Okay, fine. And that's it. So these are the properties. After that, we will discuss the multiplication. Multiplication of two matrices. Two matrices. Okay, multiplication means, so let's see the example or else direct exercise problem. So second exercise, already we started for B1, B2. So section C already completed. Okay. 3.2 second exercise. So here, first I am going to take 2 by 2 matrix. A is equal to, I am taking like A, B, minus B, A. And here, no need, direct they given the first subdivision is exercise 3.2, exercise 3.2. First question is there. Okay, let us do the first question alone on matrix multiplication. Right. First question, third, fourth and fifth subdivision. Like before that, in the first question they given A value is 2, 4, 3, 2 and B is equal to 1, 3, minus 2, 5. So here the fourth subdivision is AB, we need to find AB. Fifth subdivision is BA. BA. So you have to concentrate very carefully to do the multiplication of two matrices. So very simple, A, B. So matrix A, 2, 4, 3, 2 into like 1, 3, minus 2, 5. So whenever you want to find the matrix multiplication in the first matrix, like here the first matrix is capital A, in that capital A, you have to draw the horizontal like this. And in second matrix, you can draw the vertical line. Okay. So draw the vertical line, not line. So you can simply get it like dot. It is better. Okay, right? Now, see, whenever we want to do the multiplication, just you can multiply like this. First element of first matrix, first element of second matrix, that is clearly 2 into 1, 2 into 1 plus 4 into minus 2. 4 into minus 2. So first row, first column completed. Now first row, using first row, multiply to second column. First, what can you do? Like take first row, multiply to first column, take first row, multiply to second column. The second column is 2 into 3. 2 into 3 plus 4 into 4 into 5. 4 into 5. Right. So whenever you can use the first row of first matrix, we are going to get the values of first row alone. First row. Next, what about the second row? So before that, clearly yesterday class I explained, and last class clearly explained the order of the first matrix is 2 by 2, order of the second matrix is 2 by 2. Clearly, these two are same. The number of columns of first matrix should be equal to the number of rows of second matrix. Then only, whenever these two values are equal, then only matrix multiplication is possible. Matrix multiplication is existed. If these two values are not same, okay, columns of first matrix not equal to rows of second matrix, matrix multiplication does not exist. Okay. So what is the resultant matrix we are going to get? First and last. When middle values are equal, the resultant matrix we are going to get first and last. That is the resultant matrix of order of order 2 by 2. Okay. Here we got the first row. Then what about the second row? The second row values is related to this second row. Right? Now 3 into 1, 3 into 1,
Sir,
okay, 3 into 1 plus, yeah,
for multiplication, number of rows and columns has to be same in both matrices.
sorry,
For multiplication, does number of rows and columns have to be the same?
yeah, in this question, rows and the columns should be same, okay, yeah, it must be equal. So here it is not compulsory that, compulsory that your rows is equal to columns, but columns must be equal to rows. That is the condition. It may or may not be equal. The first and last may not be equal also. Okay, we don't think about that. But these two values must be equal. Clear, Kishore?
Yes.
Fine. So next 3 into 1 plus 2 into minus 2 and 3 into next. This first column completed, next second. 3 into 3. 3 into 3 plus 2 into 5. Okay, 3 into 3 plus 2 into 5. Once again, the B1, B2 section just concentrate here. Just I am taking here 2 by 2. Next I am going to take 3 by 3. Okay, and 2 into 1. First take first row, first column. 2 into 1 plus 4 into minus 2. And next 2 into 3 plus 4 into 5. So first row completed. Next use second row and find the second row values. Okay, first second row first column. 3 into 1 plus 2 into minus 2. And the next 3 into 3 plus 2 into 5. Okay, so now just simply by the values like 2 into 1, 2, 4 into minus 2, so 2 minus 8 minus 6. 2 3 is a 6, 4 5 is a 20. 6 plus 20, 26. 3 into 1, 3, 2 into minus 2, minus 4. 3 minus 4, that is minus 1. Next last one, 3 3 is a 3 3 is a 9. 9 plus 10. Shall we write 19? Is it right? See here, the resulting matrix having 2 rows and 2 columns. In the same way, can you find BA? So this is the AB value, the matrix AB. In the same way, find the BA. So what is the matrix BA? So BA is clearly equal to first B. B means 1, 3, minus 2, 5. And A means 2, 4, 3, 2, 5. So this is equal to 1. Right. Again, immediately you can draw your horizontal line, your vertical line. Okay. Now look at here. 1 into 2, 2 plus 3 into 3, 9. Okay. I'm using first row here. I'm using first row. I multiply to first column. So first element. Next one. 1 into 4, 4 plus 3 into 6. This is first column, second column. First column value, second column value. Next step. First row completed. Next use second row. Minus 2 into minus 2, minus 4 plus 15 and minus 2 into 4 minus 8, 5 to the 10. So clearly this is equal to what is the resulting matrix here? 11, 10, 11, 2. Is it right? Anyhow, this is the resultant matrix of BA 2 by 2. Okay, so now what do you observe here? What do you observe? So if you observe that this is matrix AB, this is matrix BA. So if you observe these two resulting matrices, is there these two resulting matrices are equal? What about AB and BA? Are this equal here? Yes, clearly
No.
not equal. Clearly not equal. So what we observe here in matrix multiplication should not satisfy commutative property. AB is equal to BA. Then only we can say that it is commutative. But whereas the matrix addition is satisfies the commutative property. To satisfy the commutative property, because A plus B always equal to B plus A, but whereas AB should not equal to BA. So that is one of the important property in matrix multiplication. Okay, a few properties are there. That way I will write on the board. So these are the answers for the first question, fourth subdivision. This is fourth subdivision, and that is fifth subdivision answer. Right? So this is commutative, this is associative. So this zero is called, your zero is called identity. Okay, additive identity of given matrix. What does it mean by identity? Whenever we add some value, we get the same value. Then that is called identity. What is the identity of a number system? 0. 0 plus anything will get the same value. 0 plus 1, 1, 0 plus 2 is 2, 0 plus 3. That 0 is called additive identity. In the same way, the null matrix. The null matrix is the additive identity, okay, of the matrices. Okay, we should not take identity matrix as identity of addition. Addition, we cannot write I plus A is equal to, it should not equal to A. It should not equal to A. We cannot say that it is a identity. But in multiplication we can use this. Okay, so these are the properties, and I'm going to write the properties of multiplication. Just you can observe a simple properties like first one is AB should not equal to BA. That is very important property. Second one is A into BC should be A into BC should be equal to AB into C, but it is associative. I'm not interchanging the matrices. Just I'm keeping as it is BC in order only. After BC, here after BC, after AB, after AB. But here A becomes B becomes A. No, not equal. But it is associative, and the third property is, so clearly third property like identity. A into I. So multiply any matrix with identity matrix. Identity with any matrix is equal to A. Nothing but what do you observe here? The multiplicative identity is unit matrix. Okay, additive identity is 0, but multiplicative identity is unit. Okay, but if you see the fourth property like A into B plus C, if I take any three matrices, I found first B plus C, then I multiplied with A. This is clearly equal to AB plus AC. This is also satisfies, and in the same way, fifth one, if I take A into KB is there, KB. So this can be written as K times of AB matrix. K is a constant. K is a constant. So these are all simple properties, right? So these are the properties of multiplication of matrices. Not commutative, it is associative. So multiplicative identity, and this is distributive laws. Okay, right. Next, let us go for like 3.2 second question. 3.2 second question, right? So what is the second question in 3.2? So in the second question, first subdivision. Here, let us, you can try the 2 by 2 first subdivision. I am going to do second subdivision. The second subdivision is clearly 1, 2, 3, 2, 3, 4. 1, 2, 3, 2, 3, 4. Can anyone tell that is the matrix multiplication possible or not? Okay. Is there matrix multiplication is exist?
Yes, sir.
Exist or not? A simple, see first you have to write the order. What is the order? How many rows are there? First row, second row, third row. 3 rows. And how many columns? 1 column. So they given a column matrix, they given a row matrix. Now we have to check whether this multiplications exist or not. Okay. So now coming to here, what is the order of this? Clearly, how many rows are there? 1 row. How many columns are there? First column, second column, third column. Right now, if you observe here, this is clearly equal. 1 is equal to 1. So what is the resultant matrix we are going to get? We are going to get the resultant matrix of order 3 by 3. 3 by 3. Okay, let us see that 3 by 3 matrix first. First row, I am taking your first row, first column. 1 into 1 into 2. 2. Directly I am writing the value 1 into 2. Okay, first row, first column, completed. Next, first row, second column. First row, second column, 1 into 3. 3. 1 into 4. See, only the thing is just multiply. 1 into 2, 1 into 3, 1 into 4 will get first row. Then second, 2 into 2, 2 into 3, 2 into 4 will get second row. 3 into 2, 3 into 3, 3 into 4 will get third row. That's it. So second row, first column, 2 to the 4, 6, 8, and 6, 9, 12. So this is the resultant matrix that is of order 3 by 3. So in the same way, you can form reversely, like you can take 2, 3, 4, and into 1, 2, 3. So what is the answer we are going to get? Anyone? Anyone? What is the resultant matrix of order in this case? Yes. So if you take here, the order will be how many rows? 1 row. How many columns are there? 1, 2, 3. 3 columns are there. What is the order here? 3 rows and 1 column. 3 rows and 1 column. Am I right? 3 rows, 1 column. 3 rows and 1 column. So see here, 3 should be equal to 3. 3 equal to 3. Number of columns is equal to number of rows. Then what is the resulting matrix? What is the resulting matrix? 1 by 1. 1 by 1. So the matrix of order 1 by 1. Then what is the name of this matrix? What is the name of that matrix? That is called a singleton matrix. Singleton matrix. Only one element. Okay, right? So now I am going to find the matrix multiplication of 3 by 3. So that question, fourth subdivision. Okay, let's do the fourth subdivision. Fourth subdivision is 2, 3, 4, 2, 3, 4, 3, 4, 5, 3, 4, 5, and 4, 5, 6, 1 minus 3, 5, 0, 2, 4, 3, 0, 5. Okay, so all C section student, so you can try to do that classwork 1 questions. All are very, very easy in matrices, right? COQs as well as classwork 1. Right? Okay, now see here, the order is 3 by 3. Here also order is 3 by 3. Fine? So then clearly matrix multiplication is exist because 3 equal to 3. The resulting is first and last. So here we are going to get the resulting matrix of order what? 3 by 3. Okay. So for that I said very clearly draw the rows and columns. Then simply it is clearly equal to like 2 into 1, 2 plus 3 into 0, 0 plus 4 into 12. Okay, fine. Next, first row, second column. So minus 6 plus 6 plus 0. Next, the third element is first row, third column. 2 5s are 10. So 2 into 5, 10 plus 3 into 4, 12 plus here, first row, first column, then this middle. First row, second column. Okay, next step. First row, third column. So 2 5s are 10 and 3 4s are 12, 4 5s are 20. Clear? Okay, first row completed. Next, use second row. Second row, first column. So 3 into 1, 3 plus 4 into 0, 0 plus 5 into 3, 15. 5 3 is 15. Okay. First column completed. Next, second row, second column. So 3 into minus 3, minus 9 plus 8 plus 0. Right? And next, second row, third column. 3 5s are 15 and 4 into 4, 16 plus 5 into 5, 25. Okay, now second row also completed. Use third row and first column. 4 ones are 4 plus 5 into 0, 0 plus 18. And next, third row, second column. So 4 into minus 3, minus 12. 5 into 2 plus 10. Then 6 into 0, 0. Okay, right now, third row, third column. 4 5s are 20 plus 5 4s are 20 plus 30. Is it clear? Right. This is the resulting matrix. Now adding all these values, we are going to get 3 by 3. So what is the resulting matrix here? Resulting matrix. That clearly 14. Yes, anyone? 0. Is it 42?
Yes, sir.
18 and minus 1. Then what about that? 15, 25, 40, 56.
56.
Right now here 22 minus 2.
Minus 2,
Okay,
70.
70. That's it. So like that, we will do the matrix multiplication. Okay. So parallelly, we will do the OBT questions also. So don't be absent for the classes. Each and every class is important. Okay.
Sir,
Yes.
sir, what is the answer for the 1 into